is Hickman, and today I'm in class making a video. Everyone say hi!
Hi.
They're excited. They're just being shy. Okay, so today we're talking about the first derivative test for local extrema. Pretty much what that means is the following test applies to continuous functions f of x at a critical point C. Okay, so just look in your book and you can get all this. Okay, so sign charts help. Just follow the sign charts and you'll be fine. Okay, but we're going to do the algebra stuff. Okay, I'll give you a quick look and then you can pause and see. That's the first derivative test. Now you can't say I didn't go over it. All right, so let's do some examples. So use the first derivative test to find local extrema and identify absolute extremum. So many big words, but pretty much we're just looking for maximums and minimums. And we'll put in where it's increasing and decreasing to, just for fun, because it's fun. All right, so first things first, we need to find the domain. It is a polynomial function, so there is no radicals, there's no denominators, which means the domain is negative infinity to positive infinity. Why do you need to know that? Because if you have endpoints, you're going to need to test it when you get to the first derivative. So your domain is negative infinity to positive infinity. So to find to find any extrema, you have to do the first derivative. So first derivative is y prime is negative 6x squared plus 12x. Okay, set that equal to 0. Okay, greatest common factor. You can take out the negative here or just take out the x. Does not matter. Y'all want to take out the negative? By the way, you can ask questions if you need to. Okay. All right, so x. Okay.
Wow.
All right. Set each equal to 0, so x equals 0. So here are your zeros. You're not going to have any undefined here because you have nothing in the denominator or a radical. And then negative 6x plus 12 equals 0. So that's going to give you negative 6x equals negative 12 and x equals 2. Okay, so right now these are your critical points. They're also stationary points. Just throw that in there, but you're not going to see too much of the stationary points. Stationary points are just where there is a derivative. There's a derivative of all x on polynomial functions. Okay, so let's sign chart this and write our intervals out. So we have this. So we have 0 and 2. Okay, why we do this, it just helps us write our intervals. So we have intervals f prime. This is the graph of f prime of x, and then we're going to get the sign. Okay, interval is going to be negative infinity to 0. This is where if you had endpoints here, that's where you would put them. Negative infinity to infinity. A number less between negative infinity and 0 is what? Negative 1. Thank you for participating, class. F prime of negative 1. Okay. Use the factors here. It's just going to be easier for you. So you're going to have negative 1 times negative 6 times negative 1 plus 12. Okay, so that's going to give you negative 6 times negative 6 is positive 6 plus 12, which is a positive. So you're going to have a negative times a positive, which gives you a negative. Okay, so right now, so far, if you're looking at decreasing, right now it's decreasing on negative infinity to 0. All right, now we're going to go from 0 to 2. So f prime of 1 is going to be 1 times negative 6 times 1 plus 12. So that's going to be a positive times a positive, which is a positive. I don't care what the number is, I just care what the sign is. Just make it easy on yourself. Stuff's already complicated. Take it easy. Okay? So for here, you have 2 to positive infinity. Okay, so you just need to pick a value greater than 2. You can't pick 2 or you're going to get 0, which tells you nothing about the sign. So f prime of 3 is 3 times negative 6 times 3 plus 12. So you're going to have negative 18 plus 12, which is going to be a negative number, times a positive. So you get a negative. Okay? So according to the first derivative test, when the sign changes from a negative to a positive, you have a min. When it changes from a positive to negative, you have a max. Okay? So before we get into extrema, let's go and put down our values of increasing and decreasing, just for extra practice. So this function is increasing wherever you see the positive, which is going to be from 0 to 2. Can y'all see that okay, or is it too far away?
Yeah.
Everybody good?
Mm-hmm.
No? Okay. Okay. All right, decreasing. Okay, is going to be from negative infinity to 0, 2 to infinity. Don't forget the union conjoined sets. Okay. Okay, so let's look at the beginning function because I want to see if we're going to have any absolute extrema. So if you're looking at this, it's a negative odd. So if it's a negative odd, think of the graph of y equals negative x. So if you were drawing the graph of negative x, it's going to be going down here and up that way. Okay, so this is going to tell you whether you have any absolute extrema. You are not going to have any absolute extrema because infinity does not count. Okay, so there is no absolute extrema. Okay, but we do have a local min and a local max. So to find that, a local min. So this is where it kind of gets confusing because you want to, I know some of you are going to be tempted to use 0 f prime, but you need to use 0 f, okay? So your local min is going to be at 0, f of 0, which is pretty easy to figure out. So you just put 0 into this right here, so that's going to be 0 plus 0 minus 3. So you're going to have a local min at 0, negative 3. Okay. So now you're going to find your local max. You're doing the same thing, except you're going to put 2 in here. F of 2. Okay. Okay, so we're going to have negative 2, so pretty much 2 cubed is 8. 8 times negative 2 is negative 16, thank you. 2 squared is 4. 4 times 6 is 24. Minus 3. 24 minus 16 is 8. Minus 3 is 5, thank you. So we got 2, 5. 1, 2, 3, 4, 5. Okay, so it kind of looks something like this. So it's going to go down. Okay, not very well, but that's okay. You can do P's and Q's to find the zeros, or you can use your calculator to go and see. I'm not getting into P's and Q's now. P's and Q's, if you wanted the rational zeros theorem, just a reflection. P is 3, Q is negative 2, plus minus factors of those, synthetic division. But I'm not doing that right now. Okay, so let's do number 2. Y equals xe to the 1 over x. Which means we have to do, so before we go anywhere, I don't really know this graph offhand, so I can't really do any end behavior or anything. So I'm going in blind. But we do know, we can kind of figure out what the domain is, okay? So x is okay. However, we have 1 over x here. So that if this was a 0, then it would be undefined, because you would have 1 over 0 is undefined. You can't do e to the undefined. Okay? So you pretty much have x can't equal 0. So just remember that. Okay? Now we're going to do the product rule. F, that one's dying. F equals x, f prime equals 1, g equals e to the 1 over x. So that's e to the u. So just a quick reminder, e to the u, the derivative of e to the u is u prime e to the u. Okay? So u prime is 1 over x. U prime, or you can also say that's x to the negative 1, which will probably be easier to do. So then u prime is going to be negative 1x to the negative 2. So g prime is going to be negative x to the negative 2 e to the 1 over x. Okay. Now we're going to do the product rule. Y prime, if you want to, you could do negative 1 over x squared. It might actually help out because I think something's going to cancel out, so I'm going to go ahead and make that negative 1 over x squared. So y prime is f prime times g. Some books do it backwards. I just like to do it this way because so you don't get the quotient rule mixed up when you get there. So 1 times e to the 1 over x plus g prime of f. So you're going to have negative, well, we'll just put x times negative 1 over x squared e to the 1 over x. So e to the 1 over x minus 1 over x e to the 1 over x. Okay? Okay, so you might be thinking, now what? Well, now you got to do your greatest common factor. Your greatest common factor is going to be what you see repeating. So you don't have any numbers here to repeat, no x's. So what you're going to be greatest common factoring is e to the 1 over x. So I'm going to go ahead and set this to 0. So 0 is e to the 1 over x times 1 minus 1 over x. Set them equal to 0. So you have e to the 1 over x equals 0. And then you have 1 minus 1 over x equals 0. So ln both sides, ln of 0 is, I think, undefined. It's either undefined or 1. Let me just confirm. Oops. I think ln of 1 is 0 and ln of 0 is undefined. Yes, logarithms cannot be 0. So you can't do anything there, okay? Because if you do ln on both sides to bring that down, you're going to get ln of 0, which is going to give you an error. So this is undefined. Okay? You can't use any number there. Or no solution is probably a better term. Now let's go over here. So you have negative 1 over x equals negative 1. Cross multiply, you're going to get x equals 1. Okay. Okay. So you're going to need to be checking 2 points, I believe, you're going to want to check, no, I guess you're just checking 1. Okay? I'm just saying this because I'm not sure if we need to check 0. Let's just put 0 in here, okay? If it's not, I mean, no, it can't be anything. It can't be anything because it's undefined there. So you just need to check 1. So if you're not following my mind track, x can't equal 0.
Please report to the office. Please report to the office.
There can't be a max or min here because it's undefined at that point. So you don't need to use it. So sign chart. Just need to use 1. And remember, don't use 0. You cannot use 0. 0 is a no-no. We're just putting that there just for a reminder. Okay, so you're going to be checking the interval from, I don't know, 0.5. So let's just do f prime of 0.5. I guess we're just going to do the interval 0 to 1. F prime of 0.5. Okay. So E 1 over 0.5. That's going to be a positive number because if you remember the vertical asymptote's right here. But I'm just going to make sure it is E to the 1 over 0.5. It is positive, so you get 7.38. If you're unsure what I'm doing this. 1 over 0.5. 1 minus 1 over 0.5. So that's a plus. So this is going to be 1 minus 2, which is a negative. Yeah, right. Negative. Okay. And then we're going to do 1 to infinity. F prime of 2 is e to the 1/2. 1 minus 1/2. So e to the 1/2 is most likely going to be a positive number because you got that vertical or the horizontal asymptote at 0 for an exponential function. So you're going to have plus and plus. Okay? So you have a min here because you're going from decreasing to increasing. Okay? I don't think you have any absolute extremum, but I'm just going to look at the graph real quick to look. So E, so I'm just, and Y equals second E 1 over, or it's X. You're using the original function, 1 over X. Okay, so everything's negative infinity to positive infinity, so you're not going to have any absolute extrema. So no ABS extrema. But you do have a local min at 1 f of 1, which is going to be 1 times e to the 1, which is just e to the 1. So 1e is where your local min is. And that's probably right here where you can check it. So if I put in, this is kind of how you can verify that you're kind of doing it right. Okay. Alright, so remember we can't use that because that's 0. So trace 1. Okay, E is 2.718. Okay, if you don't believe me, I'll do it right here. Second E. See? Graph, trace. No, 1. Okay. There you go. Alright. So that is using the first derivative test, which is pretty much what we did in 4.1 and 4.2. So all review. Concavity. Okay? So let's say we have a graph that looks something like this. Okay. Alright, and we'll make A right here. That's supposed to be the part where they're changing concavity. So concave down is frowny faces. So concave down is going to be from negative infinity to A. Concave up is going to be from A to infinity. Okay, so when it's facing down, when it's a frowny face, it's concave down, concave up. Now what we're about to do is learn what the second derivative tells us, which is going to be the point of inflection. And the point of inflection is going to be kind of like the critical point of the first derivative, but it's going to tell us where it's changing from concave down to concave up, or concave up to concave down. Okay. Okay. So you can also see kind of concavity too for the first derivative. Concave up on an open interval if y prime increases on I. All right, you can kind of see that here. We did a little bit, so see. Increases on I, so increasing on an interval right there. Yeah, kind of not really, but the second derivative will give you a better picture. So let's look at the concavity test. So the graph of a differentiable function, which means it has a derivative at the point. Okay, concavity test. If y equals f of x has a second derivative, then we can conclude that y prime increases if y double prime is greater than 0, and y prime decreases if y prime is less than 0. Okay. Concave up is going to be when the second derivative is greater than 0. So we're going to do sign charts for this one as well. So when you see a plus, it's concave up. When you see a minus, it's concave down. Okay, so we're going to find the intervals where the graph of f is concave up and concave down. Determine the domain of f first. All right, so this function has no denominators and no radicals. Or I should be specific and say no even root radicals, because odd root radicals are negative infinity to positive infinity. So your domain is going to be negative infinity to positive infinity. And if you want to go ahead and kind of get a grasp of what this graph looks like, it's negative and even. So it's going to be down and down. Okay? Which is automatically telling us that there is not going to be any absolute minimum, but there's going to be an absolute max. But we're not worried about this time, but this is just getting your brain ready to think. So let's go ahead and find our points of inflection, which is actually the next one. But oh well, spoiler alert, I spoiled it. So let's see concave up, concave down. So f prime of x is going to be negative 4x cubed plus 12x squared minus 4. Okay, go again. F double prime is going to be negative 12x squared plus 24x. Set it equals 0. You can go ahead and factor. I'm just going to factor out a negative 12x. You don't have to factor out the negative. I just feel like doing it. So it's going to give you x minus 2. Same thing as first derivative. Negative 12x equals 0. X minus 2 equals 0. So x equals 0 and x equals 2. So these should be points where the concavity is going to change. And you can kind of already guess what it's going to be for the first one, if you know what a quartic function looks like. So if you ever wonder why you had to know what those functions look like in pre-cal and algebra 2, this is why. Okay. Interval. And this is f double prime. f double prime of something. Oh, you can't see anything? I'm writing. There you go. And then the sign. Okay, always remember, try to use, instead of using this one when you're checking your positive and negatives, use the factored form. It's easier. So we have interval from negative infinity to 0, 0 to 2, and 2 to 0. Or I mean 2 to infinity. All right, so I'm going to pick a number less than 0. 1 is the best choice I'm going to choose. Negative 1. So that's going to be negative 12 times negative 1, negative 1 minus 2. So negative, negative, negative is going to be a negative. Which kind of makes sense, because if you're coming up here, you're going to be dipping down. Like if you're looking at this graph, it's going to be coming up and dipping down like that. So it makes sense it's concave down. A number between 0 and 2, f double prime of 1, which is going to be negative 12 times 1 times 1 minus 2. So that's a negative, positive, negative, which is a positive. Okay. Lastly, and then f double prime of 3, you can choose 3, 4, 5, 6, and up. I just like to choose the number right next to it. So negative 12 times 3 times 3 minus 2. So that's a negative, positive, positive, which is a negative. Okay, so what this tells us, the graph is concave down where you see the negative signs, because if you were doing a graph, it's going to look like this. That's what it looks like. Concave down is negative infinity to 0, union 2 to infinity, concave up, is going to be from 0 to 2. Okay. The next section, you're going to find that 0 and 2 are points of inflection, and that's where the concavity is going to change. So I'm just going to do a little spoiler of what this graph actually looks like. Well, I guess I can't really do it because I don't know where my max and mins are. So to remember to find the max and mins, you need the first derivative to do that. We kind of skipped over that step. But you could probably factor this. You would need, factors of 16. Yeah, I would Grady's common factor that one down a little bit before I do any factoring. So never mind. I'm not spoiling anything. Okay. All right, points of inflection. So I already told you about this. That's why we did this. So 0 and 2 would be points of inflection. These are the critical points of the second derivative. Okay. Okay. So find the points of inflection. So first, we are going to find the domain. This is a long one. Sit tight. Okay, so domain. So first you look at this one. So that one's fine. That can be any number of x you want it to be. This is where the problem lies. Okay? So your domain of f. Okay? Is going to be 9 minus x squared is greater than or equal to 0. Why greater than or equal to 0? Because square roots can be positive and they can equal 0. Like you can do the square root of 0 and you get 0. So algebra, fun stuff. Negative x squared is greater than or equal to negative 9. Divide by negative, flip the sign. X squared is less than or equal to 9. Square root, both sides. You get x is less than or equal to plus or minus 3. You could do a sign chart here, but this is why I do absolute value. So automatically make that absolute value of x is less than or equal to 3. And for a less than, you do negative 3 is less than or equal to x is less than or equal to 3. If it was a greater than, it would be x is greater than 3 or x is less than negative 3. So your domain is negative 3 is less than or equal to x is less than or equal to 3. Okay? So we have endpoints here. So endpoints are going to be from negative 3 to 3. You also can kind of see where you have an x-intercept. An x-intercept is going to be at x equals 0. Because you can still use the zero product property for this one. X equals 0, 9 minus x squared equals 0. Okay? So, there you go. So you have 0 at x equals 0. This is just extra stuff. You don't got to do it. It's just getting you ready because we're about to do the big ones. Okay, so let's do calculus now. So that's all F. Okay, so F. So I'm going to go and write F again in using rational exponents. So F of x is x times 9 minus x squared to the 1/2. Okay, product rule. And you got a chain rule when you get to G. So F equals x, F prime equals 1. Easy enough. G, however, is different. Okay? Okay, you don't have to do the U's and the V's. I'm just going to show you real quick. So to do this without the U's, which I'm going to do, you're going to be doing, you bring the 1/2 down, 1/2 times the derivative in here, which is going to be negative 2x, and then subtract 1. So it's going to be 1/2 times negative 2x times 9 minus x squared to the negative 1/2. But I'm going to do it here. So U is 9 minus x squared. U prime is negative 2x. F of U is U to the 1/2. F prime of U is 1/2 U to the negative 1/2. Oh, you can't see anything. Okay. So then G prime is going to be negative 2x. Oh, I forgot F prime of x. Whoops. So G prime is going to be negative 2x times 1/2, which is going to be negative x, times 9 minus x squared to the negative 1/2. Okay. Product rule. So F prime of x is going to be F prime of G, so 9 minus x squared to the 1/2, plus a negative number. I'm just going to go ahead and put that negative there. So plus a negative makes it a negative. F times g prime of x. So you got f here. X times x is x squared. 9 minus x squared to the negative 1/2. Okay. Okay. Next we're going to do greatest common factor. So there's no numbers in front of here and here, so that's fine. There's no x's in front of here or there. It's just that 1x. But you do have something repeating, and that's 9 minus x squared to the 1/2 and 9 minus x squared to negative 1/2. You can combine fractions if you like that way. I just do greatest common factor. Okay, so do greatest common factor. You pick the one with the lowest exponent, which is this one. So that's going to be f prime of x. I'm going to write the greatest common factor in pink so you don't get confused. So that's going to be 9 minus x squared to the negative 1/2. Okay? Now you're going to go to each one. So you're going to do 9 minus x squared to the 1/2 divided by that. Okay? You subtract the exponents. So 1/2, so 1/2 minus a negative 1/2 is going to be 2 over 2, which is 1. So that's going to be 9 minus x squared to the 1. You don't have to write to the 1. It's just giving you practice. Minus x squared, and that one cancels. Okay. F prime of x is going to be, I'm going to go ahead and put that on the bottom. 9 minus x squared, and then 9 minus x squared is negative 2x. So 9 minus 2x squared. Okay? Now, if you set f prime equal to 0, this would be where you would find your extrema. But we're just looking for points of inflection, so we're going to keep going. But just so you know, you would set this equal to 0, and you would set this to greater than or equal to 0. And then to find the extrema, you would have to check the endpoints, negative 3, 3, and whatever you got here to see what the max and mins are. Okay, but we'll keep it on going. F prime of x, f double prime. Alright, f double, well, let me just write this again. It's going to just be easy. It's going to be easier doing the product rule. You can do the quotient rule. I just prefer doing the product rule. So 9 minus x squared to the negative 1/2 times 9 minus 2x squared. So I haven't started the second derivative yet. I just prefer doing the product rule over the quotient rule. Okay. F prime, or F, is going to be 9 minus x squared to the negative 1/2. That's a chain rule. So you're going to have u equals 9 minus x squared. U prime is negative 2x. F of u is u to the negative 1/2. F prime of u is negative 1/2. Negative 1/2 minus 2 over 2 is negative 3/2. F prime of x is going to be negative 1/2. 9 minus x squared to the negative 3/2. So f prime, I know it gets confusing with the u's and the f's. That's why I indent. That's not f prime. You have to do this times that to get f prime. So f prime is going to be negative 2x times negative 1/2, which is going to be a positive x. Okay? Didn't forget about g. G is just easier. G is 9 minus 2x squared, so g prime is negative 4x. Now you're ready for the product rule. So f double prime, I'm just going to give myself more room here. So f prime of g, so that's going to be x times 9 minus 2x squared times 9 minus x squared to the negative 3/2. Okay, so that's f prime of g. So product rule is f prime of g plus g prime of f. So plus a negative 4x over here. So plus a negative 4x, which positive times negative is a negative. 4x times g up here. Or g prime of f. That f, not that one. Okay. Greatest common factor again. This time we have an x involved. So 0 equals x. And 9 minus x, so this doesn't change. I would not distribute that, just wait. Because when you find zeros in points of inflections, it's going to be in factor form anyway. So if you go ahead and distribute this, you're going to end up having to factor it out later on. So negative 3/2, negative 1/2. The smallest exponent is negative 3/2. Okay. So now you're dividing. X divided by x is 1. That comes down. That 9 minus x squared comes down. And then 9 minus x squared to negative 3/2 cancels out. So that cancels out and that cancels out. So you have 9 minus 2x squared. That's just this part. Now we're on, that's for the first term. This is for the second term. So now you're going to be doing negative 4x over x is just going to be a 4. So that x cancels out. And then you have negative 1/2 minus 3/2. So let's do that over here. So negative 1/2 minus a negative 3/2 is going to be 2 over 2, which is going to be 1. Okay. Okay. So greatest common factor is here. So for the first time, x cancels out. That 9 minus 2x squared comes right here. So see, that doesn't cancel out, but that does. 9 minus x squared to the negative 3/2 over 9 minus x squared to the negative 3/2 cancels out. And then you have here, negative 4x over x is negative 4. And then you have 9 minus x squared to the negative 1/2 over 9 minus x squared to the negative 3/2 is going to give you 9 minus x squared to the first. So you have 0 equals, I'm going to go ahead and put that on the bottom. So you're going to have x times 9 minus 2x squared minus 36 don't forget to shoot with the negative, plus 4x squared is going to be 0 equals x. Negative 2x plus 4x is 2x squared. 9 minus 36 is negative 27. Okay. Now you're ready to find points of inflection after all that. So the top is the zeros. So for the zeros, you set the numerator equal to 0. X times 2x squared minus 27 equals 0. X equals 0. 2x squared minus 27 equals 0. So you're going to get x equals 0 and x equals plus or minus 20 square root of 27 over 2. I know it feels like a never-ending problem, but it does indeed end. Let's go ahead and determine what 27 over 2, because that will square root 27 over 2, because that will help us with our 1335. Oops. 27 divided by 2 is 3.67. So it's just good to kind of get a decimal. That's kind of around 3.67. Undefines. So it's over here, set that to greater than or equal to 0. It's even root. So 9 minus x squared is greater than or equal to 0. We already know what that turns out to be. It turns out to be negative. Oh, that's just greater than. Greater than, not greater than or equal to. Why? Because you're in the denominator. If you set equal to 0, you'll get a 0 in the denominator, and you don't want that. But we kind of already did the algebra up when we found the domain of f, so we know instead of less than or equal to, it's going to be negative 3 is less than x is less than 3. Sign chart. Almost done. I know, it's a workout. So you have negative 3 and 3. You do have to check negative 3 and 3 because they're defined up here. And 3.67 is out of the way. So we don't even have to worry about the square root of 27 over 2's. Hooray! So that's outside the domain, so that doesn't even matter. So we don't care about those. So all we got to worry about is 0. So that makes our life easier. I'm thankful. I don't know about you, but I'm thankful. Okay, so interval. So you got negative 3. The only reason why it's brackets is because of what you got in the domain. Okay, negative 3 to 0. I'm going to choose f double prime negative 1 and put it right in f double prime here. So you're going to have negative 1, 2 times negative 1 minus 27 over everything that comes out here should be positive because we already went into the domain, so that's just going to be positive. So let's just make that easier on ourselves. So that's negative 2 minus 27. That's a negative. So we got a positive right there. And then you have 0, 2, 3. F double prime of 1 is going to be 1 times 2 times 1 minus 27. So 1, negative, positive. Positive, negative, positive is a negative. Okay. So, we have a point of inflection at 0, but wait, we're not done. That's our x value. To find our y value, you need to put it into the original function, f of 0. So that's going to be 0, 0, square root of 9 minus 0, which is just 0, 0. Okay? So that's the point of inflection of that problem. And I'm going to graph that problem so you see kind of what it's going to be. So that's going to be x times the square root of 9 minus x squared. Oops. Okay, that's what it looks like. Okay. All right, and that's it for this session.